Good day, students. Today we're going to look at quadratic functions part 1. This is taken from chapter 4 and book 2 of your math 1026 booklets. It covers objectives 4.9 up and 4.10. So pages 67 up to 82. So you can, this is a summary of everything. And you'll notice I have a chart there on the screen. And on that chart in the very first row I have written the quadratic form. Okay, let me just get my pen working here. The quadratic form of a, or the vertex form of a quadratic right here. See it? Called the vertex form. Well, y equals a outside of x minus h all squared plus k. And then across from that I give the different information. The vertex, of course, is hk from that. The direction of the opening and so on. And that's what we're going to look at, different examples. So this is called the vertex form again of a quadratic. Now the equation is called quadratic, or a quadratic function. The graph of which is called a parabola. So the equation is called quadratic. The graph of a quadratic is called a parabola. And I have several different parabolas there listed down in that column. And we're going to go over each column by column. Now this video is going to be a bit lengthy, so if you want to fast forward anything you understand, just go ahead and do that. Okay, now let's look at finding the vertex from that form. Now notice it's x minus h gives you h, so it's opposite for x, and plus k gives you plus k, so it's the same for y coordinate. Okay, so opposite for x, same for y when you're doing a vertex. So x plus 2 gives us what? X plus 2 gives us an x coordinate of, that's right, negative 2. And let me just write that a little clearer. Negative 2. And the y coordinate is negative 1, right? Whatever y is same. Okay, now next one, we have x plus 1 in brackets all squared. Therefore the x coordinate is, that's right, negative 1. And the y coordinate, well, there's nothing written here. There's nothing added or subtracted here. Now remember, the number in front, the a in front, which we call a value, look, that has nothing to do with the vertex. Nothing. I don't need any of those values to find the vertex. Okay, none of them. So what tells you the vertex is x squared, or x plus something squared, or x subtract something squared. That gives you the x coordinate. The y coordinate is always added or subtracted after. Now in the second example, there's nothing added or subtracted after, right? So you could actually put in plus 0. So the y coordinate is 0 for that one. So the vertex is negative 1, 0. Next one, the x coordinate is positive 4. Remember, opposite for x when it's inside brackets. Same for y, so negative 4 and negative 2. In the fourth example, you see that we have just x squared by itself. It's not in brackets, it's just x squared. That means the x coordinate is 0 of the vertex. Alright, so this one's going to be right on the y-axis, isn't it? Because when x is 0, that's going to be a y-intercept. Okay, so let me just write that again. 0. Now what's the y-coordinate? The y-coordinate is what's added, which is plus 5. Next one, we see negative 6 outside of x minus 3 in brackets. So that means the 3 is the x-coordinate. Now there's no added or subtracted y value here. So the y value is understood to be 0. Next one, we have negative 5 and positive 19. And then the second last one, see, I'll give you a second now to see if you can do it yourself. And if you said 0 for x, negative 4 for y, you are exactly correct. And the last one is positive 8 for the x coordinate and positive 9 for the y coordinate. So that's how you find a vertex. Next column is asking you for the direction of opening. Okay, which way does the parabola open? Now we know parabolas open up or down, right? When they're in the form y equals. So if a is less than 0, so in other words, if a is less than 0, if a is negative, a is the number in front, this number here. If that's negative, then it opens down. If it's positive, it opens up. So this one is fairly quick. We'll do this one, I'll change colors. This one is fairly quick. So a is 1/3 in this case, which is positive, so it opens up. A in the second one is also positive, therefore it opens up. A in the next one is negative 0.25. That's a negative value. Don't matter what the value is, just positive or negative. So this one opens down. Next one is positive 3/7, opens up. Negative 6 is the A value, opens down. Negative 2 opens down. Negative 3 also opens down. And negative 1 so also opens down. Okay, that's pretty easy. Now, we say the vertex is a maximum or highest point, or it can be a lowest point called a minimum. That's very simple. If the parabola opens up, then the vertex is the lowest point on the graph. So if it opens up, that means the vertex is a minimum point. So if it opens up, it's minimum. And you already determined if it's opened up or down. So if it opens up, this one's a max. This one is also a min. And then the last four open down. So they're all maximum points. So when it opens down, vertex is a maximum. Now the axis of symmetry is the line that divides it right in half. Okay? So now think about that. It's the line that divides it right in half. Now, I think it's time we looked at one. So let me bring up my graphing calculator. Let's look at the very first one. Okay? Now, go to your y equals button. I've already hit it here. Y equals. Let's put in the first one. So it's 1 divided by 3. I'll put that in brackets because it's a fraction. In front of, open your bracket, x, now the x button is right there, minus, or no, plus 2, close bracket. Now square that, and then hit minus 1. Now, we know the vertex is at negative 2, negative 1, and it opens up. Let's see if we were right so far. So you can see it at negative 2, negative 1. There's the vertex, and the graph opens up. And it's a little bit wider than normal. We'll talk about that in a second. Now the axis of symmetry is the line that divides it right in half. And I'm going to change my window just slightly here, so you get a better look at the x and y coordinate. Oh, I forgot to change my y. Let me go back and change my y. So let's go negative 8 to say positive 2. Positive 3, and let's see if that helps. See it a little better. Okay, let me change my. And you can change the play around with the window till you till you see it. I'm going to change that to negative 4, and say I'll go up to 6. Alright, so there's, I'm just trying to clarify. Look, it's negative 2, negative 1. See, the vertex, negative 2, negative 1. So negative 2, negative 1. And it does open up, therefore negative 2, negative 1 is a minimum. The axis of symmetry is the line that goes right down the middle. Now I can't draw it on the calculator, but it's x equals, because it's a vertical line. It goes right down through the middle of the graph. So the axis of symmetry here is x. Alright, x equals h. Now what's h in this case? H is simply the x coordinate of the vertex. Okay, let me just change colors now. I'll go back to let's try a blue. So now you must write x equals and the x coordinate of the vertex. So x equals negative 2. Right? So if you know the vertex, then you know the axis of symmetry. X equals negative 1. X equals 4. Do you see where I'm getting them? Right? Negative 2. The x coordinate of the vertex, negative 1. X equals 4. So you can see where I'm getting all of these, right? Alright, so the next one, of course, is x equals 0. X equals 3. X equals negative 5. x equals 0 again, and x equals 8. So there's your axis of symmetry. Now, the next one is asking you, is the graph more narrow or wider than normal? Okay, normal is when a equals 1. Okay, when a equals 1. Now we'll use the absolute value signs here. See the absolute value sign around a? That's just saying ignore the negative sign, right? If that a value is less than 1, then the graph is going to be wider. Okay, if it's positive 1, it's going to be more narrow. Or positive 1, it's going to be regular. If it's, or negative 1, because the absolute value makes, right? The negative sign makes no difference to narrow or more wider. And bring up your calculator now. We've already graphed. Okay, we've already graphed the first one. Hold on, it's not appearing properly here. Let me try that again. Okay, looks like I had to reopen it. Hold on 1 second. Screen will flash black. See if I get it correct this time. There it is. Okay, let me move it down into position. Now, I've already graphed the first one, haven't I? So let's see how wide that is. Now let's graph the next one. Okay, so y equals, let's go to the next graph. So I'm going to put in the next one. 3 outside of, okay, x, alright, there's x plus 1. And I'm going to square that value. Okay, there's my next parabola. Let's graph it. Now there's a fairly wide one. See? Now see how more narrow it is because the number in front is 3. So the bigger the number in front, the more narrow it is. The less the number in front, of course, the wider it is. 1/3 is less than 1, so that's going to be wider. This is going to be more narrow. Okay? So, and you can graph all these to see them. But the greater the number, the greater the a value, ignore the negative sign, so greater absolute value of a, the more narrow it is. The smaller it gets, the more wider it is. Okay? Now, so in this one, a is 1/3, which is less than 1. So my answer would be more narrow, or more wider here. So this one will be wider. That's how I get that answer. Okay? Wider. Alright, let me just get rid of that so it's not messing up the whole chart. Wider. Okay, the next one is positive 3. That's greater than 1, so this is more narrow. The next one is more, I'll just write narrow for sake of room. Next one is negative 0.25. Now 0.25 is a quarter. Ignore the negative. 0.25 is less than 1, isn't it? It's less than 1, so this is wider. Okay, 3/7 is also less than 1, so this would be wider than normal. Normal is when it's equal to 1. 6, that's going to be a very narrow graph. Okay, because 6 is it's a large number. So let's just bring up the calculator again and look at putting 6 in. It's going to get narrow, isn't it? Let's have a look. So I'm going to add the third equation here now. Let's look at that one. We put now it's going to open down because it's negative. First of all, negative 6, open bracket, x subtract 3. So I'm putting in that one and square that. It's a quadratic. Now watch. Okay, we can't see it because of my window. You can barely see it. So I'm going to change the window back to a normal window. Negative 10. Oops, that should be negative 10. Negative 10 is, there we go, 10. For some reason, I'm getting 11s. Y minimum negative 10 and Y max 10. Well, let's graph that. There's the first one. That was 1/3. There's 3. Now watch how skinny 6 is. See, even skinnier. Or more narrow, whatever way you want to say it. Okay? So the more narrow that is. Alright, so 2 is going to be more narrow than normal. A 3, more narrow. And 1. Okay, so this is regular. Regular width or standard width. Okay? Now, Notice I'm only asking for range in the next column. I'm not asking for domain. Okay, not asking for domain, because the domain for all of a parabolas that open up or down, the domain and range is simply all reals. It's the same. Every parabola that opens upwards or downwards, all right, the domain is all reals. So I'm asking you for the range. Now, if we got a maximum or minimum point, all right, I'll bring up the quadratic again just to look at the first one. So I'll go back and delete the other two. So let me just clear this one and clear this one, okay, and look at that graph again. So that's the very first one, 1/3 outside of x plus 2 all squared minus 1. Notice there's no y values being used here. So if it opens upwards, okay, let me move it over. If it opens upwards, okay, then it's greater than or equal to the k value, the y coordinate of the vertex. So here the lowest value on the graph is -1. So it's greater than that, right? So it's always above that. So if it opens up, we're going to say, all right, so anytime it says up, we're going to say y greater than or equal to. If it opens down, we're going to say y less than or equal to. So if you know if it opens up or down, then the problem is not that difficult, right? Coming up with the range. So this one opens up, so it's y greater than or equal to. This one opens up, so it's y greater than or equal to. Down, y less than or equal to. Up, y greater than or equal to. Down, and the rest are down, so I'll just fill them in quickly. So y less than all the way down. Now all you put in now is the k value. It's the y coordinate of the vertex. What is the y coordinate of the vertex? There it is right there. So that goes in. Just take the y coordinate of each one and put it in. So in this case it's -1. Y greater than or equal to 0. Y greater than or equal to -2. Y greater than or equal to 5. Y less than or equal to 0. Less than or equal to 19. Less than or equal to -4. Less than or equal to 9. Okay? So there you have. Very easy to get the range if you know the direction of the opening. Right? So up, we say greater than or equal to k. Down, less than or equal to k. Now this pops up sometimes, the word value. Okay, max or min value. Now don't get confused by that. Max or min value simply means, okay, max or min value just means the lowest value on the graph, and that's the k value. Okay, so don't get confused by the word value versus point. So point means the vertex, right? But when they ask for the actual value, okay, they're just talking about the actual lowest value on the graph, which is the y value of the vertex. So these are all y equals. Very simple. Y equals. So it's very similar to the range. Look at the range next to it. I'm telling you the lowest value on the graph, okay, is the y coordinate of the vertex. Alright, so the lowest value on the graph. Okay, there you have it, fairly quickly. The last one is the y-intercept. Now the y-intercept always occurs when x is 0. Sometimes you're asked for it. In every one of these, you have to work it out. Okay, you have to actually work it out. So I'm going to do these on the calculator and do them fairly quickly. So if I look at the very first one, okay, I'll go back and quit. No, won't let me quit. Go to screen clear. Alright, so what I have in the first one is 1/3. Okay, oops, forgot my division sign. 1 divided by 3, open bracket, okay, x plus 2. Now put 0 in for x to get the y coordinate. 0 plus 2. Now you could do these graphic on the graphing calculator as well. You could graph it and just look where it crosses. But if you want an exact number, most people do it this way. I'm going to square that and then subtract 1 and hit enter. Right? So the y coordinate here, just let me check something. Okay, seems to be 1/3. If I put 0 in there, yeah, positive 4/3 minus 1. Yeah, so it's 0. I'll change color here, hold on. Let me go to a different color. 0 and 1/3. Right? So put 0 in for x and solve. That's what you do. Put 0 plus 1 is 1 squared. That one's going to be 0.3, and you can check these on your calculator. I'll do the next one on the calculator. It's a little bit more difficult. Negative 0.25, open bracket, 0 subtract 4, close bracket, squared, minus 2. And the answer is negative 6. So this one is 0, negative 6. This one's easy because it's the same as the vertex, because it's just x squared. The next one is 0 minus 3, which is minus 3 squared. Okay, and again, if you can't see it, I'll bring up the calculator. We got negative 6, open bracket, 0, subtract 3, close bracket, squared. Okay, and we hit enter on that. It's quite huge. It's negative 54. So negative 54. The next one is a little bit more difficult to do in the head, so let's grab the calculator again. I'll clear the rest, and let's say we have negative 2, open bracket, 0 plus 5, close bracket. Oops, I forgot. This plus sign didn't come up. Plus, oh, back too far, 0 plus 5, close bracket, squared. There we go. Plus 19, and we get negative 31. So 0, negative 31. Next one is an easy one because it's the same as the vertex, 0, negative 4. And the last one, okay, calculator one more time, negative 8, or no, sorry, let's go back one, open bracket, 0, subtract 8, close bracket, squared, plus 9, gives us negative 55. So the last one has 0, negative 55. Okay, that summarizes about everything you'll be asked in terms of when giving an equation in vertex form, the different questions you could be asked about its parabola.